Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Kito Man, who will be presenting on the topic of GraphQL Distilled. If you have any questions for Kito as we move through today's presentation, feel free to ask it in the chat or use the Ask a Questions tab. Before we get started, the Jakarta EE 10 release Tech Talk is happening on June 28th. Mark the celebration of the community-driven innovation release of Jakarta EE 10. Now, without further delay, Kito, over to you.
Here we go. Okay, so there's my intro. My 10-year-old daughter did that, so I have to include that. Let me change to the right screen here. So welcome. Today we're talking about GraphQL. So this session is called GraphQL Distilled for Java developers. And I'll be talking about what GraphQL is, how it works, and also about how it's implemented specifically in MicroProfile, but also Java in general. So first, let me talk a little bit about myself. My name is Kito. I'm the principal consultant at Virtua, where we do training, consulting, mentoring, etc. on basically all sorts of technologies, mostly work with larger companies and government, but also startups sometimes. Usually working on backend Java, cloud native stuff, but also front end as well, Angular, React, etc. Also web components. So that's my job. That's what I do on a daily basis, is work with those technologies. Also, we do mobile, etc. I'm also a Java champion. I am I've worked on several Java community process expert groups. I'm a member of the Jakarta EE Guardian Leadership Council and a Google Developer Expert on web technologies. And I'm also the co-host of the Stacked podcast. And if you like podcasts, I encourage you to check it out. We basically focus on Java, front-end development, just enterprise development in general, and also best practices, all sorts of fun stuff. And we've had lots of great guests lately as well. And we've got a new episode coming up soon with Holly Cummins, who actually works on the Quarkus team. So we've got lots of great people on the show, and I have a few co-hosts that are amazing. So if you like it, check it out, stackedpodcast.com. And I also let's see, I can't even read my other point here on the screen, but here we go. Let me hide that. There we go. Yeah, I speak at lots of conferences. Okay, that's not very interesting. All right, so before we begin, I'd like to hear a little bit about the people on the in the session. So if you can just in the chat, just briefly put if you've worked with GraphQL before, if you're using MicroProfile, and what you're hoping to gain from this talk. So if anyone can just throw stuff in there, that would be great. Okay, so we got a newbie there. All right, a few newbies, which is great because this is more of an intro session. So if you were a GraphQL expert, probably not the best session for you. All right, so we've got a few GraphQL newbies. Excellent. New to this, but experience in backend. Okay, excellent. Okay, yes, and I do different versions of this talk, but this one is more geared towards backend, so I think this will work out well. Okay, so first question is, what is GraphQL? So what actually is it, and what is the whole point? First thing I'll point out is what it looks like. So on the left here, you have a GraphQL request, and on the right is the response. And you'll notice one thing here initially, which is that in the request, you specify exactly which properties you want back. So you say what data you want to be returned from the backend. And of course, the backend will return that. And basically, we're talking about a completely different approach to client-server communication, meaning that we're not really doing REST, we're not doing gRPC, we're not doing protobuf, we're not doing SOAP or WSDL. we are doing something completely different. Of course, the transport mechanism still is by default HTTP. So obviously not REST. GraphQL was created in 2012 by Facebook. And of course, they have very specific needs, and especially when it comes to transferring information about users and basically a graph, right? So you can think of Facebook as a huge social graph. So it was open source in 2015, and the GraphQL Foundation was started in 2017. And that consists of lots of different companies. And it's actually been adopted by a large range of companies as well. This is a partial list, obviously, but you see that we've got Lyft, Twitter, GitHub, PayPal, Starbucks, Shopify, Yelp, Wayfair, etc. So lots of big companies have picked it up over the years. And I should mention Netflix has actually started using it as well. So why would you want to use it? Well, first, let's look at the benefits. So one of the key differences, and I think it simplifies the client usage, is that there is a single consolidated dynamic endpoint. So as opposed to having an endpoint for each particular API call that you've built, you basically have one endpoint, which is usually /GraphQL. So it's like, essentially my microservice /GraphQL, or my BFF /GraphQL, whatever. And all the queries go into that endpoint as opposed to having a whole bunch of different endpoints. Another really awesome feature is support for subscriptions, which allows you to essentially push data back to the client. So basically, anytime you need to do any sort of server push technology, GraphQL is actually really cool for that. As long as your API, as long as the library you're using supports push. Another key difference is that there's a defined data format, which means that when it comes to client requests and responses, there is a specific way that they must be formatted, and there's actually a typed schema. So whereas a REST doesn't really care how things are formatted other than request parameters and data being posted, GraphQL basically says if you're going to communicate with this particular endpoint, there must be a schema defined, and that schema is typed. Another key difference is that with GraphQL, the client decides what data it wants. And that basically means that you can cut down on the amount of traffic being sent back and forth. So if the client only wants all the people on the system, but only wants the first name and the last name, it can ask for just those two fields, just those properties, and not worry about getting a whole bunch of extraneous data that it doesn't need. So that means that, let's say you have 5,000 records coming back. If you can specify only the fields you want, the amount of data being sent back and forth is going to be a lot smaller. And because of that, and because of the way things are designed with GraphQL, when you implement it, your server can decide where to get the data. So basically, the client and the GraphQL implementation have a defined schema, but GraphQL doesn't care about where the data comes from. It has nothing to do with that. Same way REST does. REST has nothing to do with where the data comes from. So for GraphQL, often it's used for what are called backends for front ends. So basically, let's say you have many different microservices running. You can actually consolidate an API across all of them that's well suited for the client that you're working with. And that gives you some real flexibility. And we'll talk about how that's enabled on some server products as well on the cloud side. So of course, GraphQL has some benefits, and part of it is to address perceived drawbacks of REST. So with REST, a lot of times you end up with writing several different endpoints, and you'll basically end up returning data, right? Of course, and you can decide what data you're returning on the back end, but you basically are sending everything to the client unless you spend a lot of time parameterizing your API calls to send only certain sets of data, which can be kind of tedious. Also, often data is split up amongst several calls. So you may have a very well-defined API in REST, and several different calls are required for the client to get back a particular set of data. Also, REST doesn't give you a specific format. You can send whatever you want back and forth in REST. It can be JSON. It can actually not be JSON. So you have a lot of flexibility, but because of that, there's nothing really keeping you from sending, strange data back. Also, REST does not have a push standard either. So those are some of the drawbacks of REST. So let's look at a quick demo. Well, not that quick, but let me just do this here. So you will see here, there is a little client here. So this is a GraphQL client, and generally a GraphQL client is going to be very similar to Postman. This one, let me clear this out, is called Altair, and it's pretty good. It's not stellar, but for GraphQL, it actually isn't a lot better than Postman. At least the GraphQL support I saw in Postman, last time I looked at it, was pretty poor. So it's better to use a client which is known for working with GraphQL. This is one. But also there's a really popular one called GraphQL, which is a React client that is really easy to embed inside your application. So sort of like you might have an embedded, I was going to say, sort of like some of the Swagger stuff that's generated by some server libraries where it'll actually let you create queries against it. So GraphQL is sort of like that. So let's start out with a very simple example. I will look not at that one, but at this one. Okay. And Altair will complain, but I think we'll still be okay. Okay, so let me clear this out. On the left here, we have a very simple query. And right now I'm actually using the GitHub API. And GitHub has a very extensive API that is all GraphQL based, which is nice. Hold on one second here. Okay, so basically what I'm doing here is I'm looking for all of the issues in my own repository. There's a sample app I have out there called GitHub repo lists that basically just pulls a list of repos and displays it in a web component. But for our purposes, we're just talking to GitHub and getting metadata about the repo, right? So we want to get back the ID, the name, the issues, total count, how many stargazers there are, and the primary language. So if we run this, we get some data here. Okay. And you see we have this data property, which is usually the root that's returned, and then all the data coming back. So we've got the repository we asked for, the name, the issues, stargazer counts, all the data we asked for. And of course, we can specify the data. So, if we got rid of name, now we don't have the name returned. So we can specify exactly what we want to get back. And now if you're curious about how this works at the network level, take a look down here. And if we just send the request, let me make this bigger. Okay, so you see the endpoint is GraphQL. And the payload is basically the operation name, which is the name of our query, and the actual query itself. Okay, and that's basically all it is. So we just send the operation we're using and the query. And then we get our response back, which is the data that you just saw. So this is all very straightforward. This is actually HTTP. It's a post request. So usually GraphQL requests are post requests. So that's a very simple example. So let's move on to something a little more interesting. So let's look at some basic queries. Okay. So this is pretty similar to what we saw before, right? We've got a simple query up at the top here, and we're looking for a repository. We're getting issues from a repository, and this time we're looking at the prime faces repository. But we've got something a little different here. We actually are sending in a filter into when we specify what issues we want, and we're getting only the open issues, and we're getting the first 50. So we could send a result, send a request, and get the result back for that. Okay. So notice this is looking a little bit different, though. We've got the repository name, and we've got issues, edges, and then the node, and then the title. Okay, so we're basically getting a graph representation of everything here. Okay, and that is up to the designer of the schema. So if you don't want to use edges and nodes, you don't have to, but that's how their API is designed. So here's another query, and here we are doing a search specifically for different repositories. So we're not looking for issues now. Now we're just looking for repositories. And we're getting back edges and nodes, and we're basically saying if it's a repository, which it should be, then we want to get these properties from it. And this basically points at one of the key things about GraphQL is that you're basically dealing with a typed system, right? And each of these nodes can be one of many different types. So this allows us to say, okay, if it's a repository, return these fields back. All right, so we get back GraphQL Java, which is a library for working with GraphQL on the server side. And we see how many stars it has, lots of stars, created at, watches, how many watchers it has, how many issues it has. And then we get other ones as well, because this is a search, right? So we're getting all the different ones that match our query, okay? So that's another query. And this is a similar query, but you notice here, we're basically looking for issues for nodes of type issue. So it's the same idea, but because we're getting back nodes, we need to, again, specify the type that we care about. So we're getting issues back here. Okay. And notice we've got the whole body of the issue as well. Okay, so those are some basic queries. Okay, no questions so far. And let's look at another feature. So you notice down here, there's this little thing called variables, right? So let's look at what that means. Okay. So you notice this is very similar to what we've seen before, but there's this little $ query thing in here, okay? So this is basically saying we are supporting a variable that can be passed into this particular query, okay? And it's of type string, and it's optional. I'm sorry, it's required, excuse me. Because if we get rid of this, well, first of all, this is what the variable looks like. We've got query and circuit breaker, okay? And if we run it, we will get the results back. So looking for everything with circuit breaker in it. If we get rid of this, we get an error back, right? Because it expected the value of this query variable to not be null, okay? So the exclamation point basically says it's required. Okay, so inside of the actual request, basically what we're getting is, let's make this bigger. So we're getting a payload back, or I'm sorry, this is the payload that's being sent, and you see all it's basically saying is, you know, this is the value we're sticking in here. We're sticking in this query value, and that's going to be inserted into our query. Okay. So that's how variables work. You can parameterize any query that you want that way. And next, let's take a look at fragments. So It's down here. So we've seen this ability to specify properties based on the type, right? But we can also take any segment here and actually throw it into a fragment. So this is a fragment that's saying, oops, where is it? Fragment repo fields. So this is basically saying we're creating a fragment called repo fields, and we can insert it into another query. So this down here is doing just that. And so it looks sort of like the spread syntax in JavaScript. Basically, we're saying we want to use a particular fragment. So this runs pretty much the way you would expect. We get all of the nodes back that are of type repository. Okay. So you can use fragments as well. And there are also directives. So what directives do is they allow you to basically extend the GraphQL language. So there's only two directives which are included. There's include, which is just a conditional, and there's also skip. Okay, so this is basically saying I only want to include the name if of the language if show language is set to true. So right now, show language is set to true. So I'll go ahead and run this query. And you see for the primary language, I have the name. Okay, I change this to false. You can see that I no longer have the language being shown. Okay, so that's kind of a useful directive, but the real power of directives is that you can create your own directives. So if you're implementing GraphQL support on the server, you can actually, depending on the libraries that you're using, you can add your own directives, and that can mean all sorts of things. So you'll find also that some cloud services that use GraphQL have their own directives as well. So think of directives more as an extension point, and there just happen to be a couple useful implementations in the default spec. Okay, so the last one I want to show is mutation. So all the queries I've shown so far are all about retrieving data, but what about actually getting pushing data? What about updating? So that's supported as well. So if we go here, we'll see mutations. So those are called mutations in GraphQL. And basically, it's like you would expect. You basically call, or you call a mutation. You pass in input parameters, okay? And then you get back data, and you specify what data you want to get back. So usually you will get something back that represents what the operation that you performed. So I'm going to create a new issue in my GitHub repo. And there it is. And I've created a new issue here called keto with a title demo and a body demo. Okay. So if I were to go to my GitHub repo, I would then find this issue created because I just did it programmatically. So you can create as many mutations as you want, just like you can with queries. But usually, you probably will have a lot more queries than you would have mutations. So that's a quick example of what GraphQL looks like. So I've got a question here. So we could say it's a filtering mid layer we can apply over data source backend. That's an accurate representation. I wouldn't say that's all it is, but that's definitely a good portion of what you can do. So your backend, you might actually be returning a huge amount of data, but the GraphQL layer can actually filter that out and return only what the client asks for. So it does give you that ability. So let's talk a bit about schemas now. So I've mentioned before that the schemas are typed and that you have to have a schema in order to build an application. So think of it really as a type-safe contract between the client and the server. It is the way they both need to agree on it and work that way. And generally, if you define a schema, the client and server will work together fine, because when you almost always are going to be using a GraphQL library on the client, and that GraphQL library is going to look at the schema and decide what it can do. And by the same token, the server library that you're using is going to be looking at the schema, deciding what it can accept. So usually they work pretty well together. And of course, the client can't request anything that's not defined in the schema. It can't make any calls which are not defined there. So it's very, very strict in that way. And one of the key differences is that with GraphQL, the schema evolution is handled through deprecation. So there's no like version 1, version 2, version 3 like there is in REST. There's really just, you can deprecate different parts. And to me, this is sort of good and bad. It's good in the sense that it's easier to manage, and it matches pretty well the way we handle evolution in Java. But on the flip side, unless you are very good about handling those deprecations and then removing them and making sure your clients are aware, you can end up with a lot of deprecated parts or deprecated queries or fields, etc., that your clients may still be using. So it's good and bad. So let's look at a demo. So what I want to show you is this. So this is actually the schema for GitHub. So this is essentially what they provide. And you'll notice it's really huge. It is 40,000 lines. So they have a very, very rich schema, which most organizations will not have. But they've also, they define some directives as well. Okay, so they have one for preview, one for possible types. But let's start with sort of the main part. So every single GraphQL schema is going to have this sort of top-level element. It's not the top of the page, but it's not the top of the file, but it's sort of the entry point, called query. And inside of it, you'll put all the queries that you support. And you can see this is how you do comments. And you basically can define your own types. So if we look at the, let's see, we look at repository here, okay? This was the repository query we were looking at. You can specify the name of the repository and the owner. And what it returns is a repository object, which looks like this. And you notice that looks very similar to a lot of programming languages, and we actually can implement interfaces. So a repository is a node, it's a package owner, a project owner, repository info, it's starable, and it's subscribable, et cetera, et cetera. And you can see also we've got properties, the assignable users, and you see here we have parameters that we can send in. So whenever we request the assignable users property or assignable users properties, we can decide what we want. So we can get a list, we can decide before or after, so this allows you to do pagination, and then the query to basically query against that list. Okay, and let's look for something a little more obvious. So there's collaborators, right? So you have a list of the collaborators, the affiliations. Again, you can do pagination. And for kicks, let's look at the collaborator affiliation. So collaborator affiliation is an enums. This is another type that's supported. And enums look like you would expect them to. Okay, a collaborator can be all collaborators direct outside, et cetera, et cetera. So you've got comments here. We've got some more enums. And remember, this exclamation point means that it's required. Okay. Okay. And so that's basically the idea. Obviously, there's a lot to this. This particular schema, it's very, very complicated or extensive, I should say. But there's also, let me show you the mutations. Okay, so these are the mutations. Okay. So these are all the updates you can do. You can accept things, you can add comments, you can add a project card, columns, etc. So these are all the things you can do this is the entire GitHub schema. So if we look at one of these, you'll see that there's, if you wanted to accept a topic suggestion, there's an input object. So this is basically what I was talking about earlier in the sense of an object that's defined for accepting query parameters. So, or mutation parameters in this case. So we look at this, and we see you have to have a mutation ID, a name, and a repository ID. Okay. And you see they've got basically their own directive here saying this can only be an ID of type repository for the concrete type. So this gives you an idea of what you can do by defining a very, very well oiled schema that works well for clients and servers. So that's the schema here. Oops. Yeah, that's the right screen. Okay. So when you build out a schema for your GraphQL application, there's a couple different approaches you can use. One is what we call the schema first approach, where we basically say you work as a team with whoever's doing the client and with whoever's doing the server to build out a schema that works for both of you. And this works well in teams where you, for example, you might, let's say you're designing your APIs first, and then the front end is going to want to build it while the back end is building it. So you have the flexibility for the front end to work with a known contract before you've actually built out the entirety of the back end. Okay. It also works well in situations where you want to do a lot of collaboration with the front end. Another option is the code first approach, and this is where you just basically build out usually the backend code and then generates a schema for you automatically. And the benefit of this approach, excuse me, is that it's usually a little faster, right? And it's more agile. You can sort of build things dynamically. But if you have a client team that needs something to work with, it's going to be a little harder because the scheme is going to be constantly changing. However, if you're building out the backend first, or if the same people are building front end and back end, it might work out very well for you. The key thing is to make the decision up front. You don't want to be making it, in the middle of the project or changing your mind. That's going to cause a lot of problems. So it's more of an upfront decision. Another thing which can impact this choice is what libraries you're using. Some libraries don't support schema first or code first, so you got to make sure that you pick a library that does what you need it to do. Okay, so that is all about the schemas. So let's talk about subscriptions. So as I mentioned before, subscriptions are basically the ability to push data from the server to the client. To me, this is really one of the most compelling features of GraphQL. It's just that this is pretty much built into the spec. As long as you have libraries on the front end and back end that support it, you're good to go. And also, it's transport independent. So there's no rule in terms of the specification that says subscriptions need to support, one protocol over the other. However, WebSocket is the most common. So you'll find WebSocket is pretty much universal support, and other ones it really depends. But I've seen, MQTT ones for IoT stuff. I think I may have even seen like JMS. You could really use any sort of messaging layer as long as you have support on client and server. It's also server sent events as well. But again, WebSocket is the most prominent. So I'll show you a quick demo of this. So what I've got running here is actually Quarkus. And I've got if you're not familiar with Quarkus, it is a MicroProfile and Jakarta EE implementation that basically is optimized for microservices from Red Hat. I've got experimental support for GraphQL subscriptions running here in Quarkus. And basically what I'm going to do is go over here, and I've got this page running, and you see I'm just going to hit connect. Okay. And you'll see it's updating dynamically 1, 2. It's basically just creating a whole bunch of random objects and sending back the data. Okay. So what's happening inside in terms of the network requests is, and let me, okay, we missed the request. Let's start over here. Okay, we look for, There we go. So you see we've got this GraphQL request, right? And instead of HTTPS, it's WS because it's a WebSocket, right? And you see here, we're just pushing all the requests in. The initial query is just like you'd expect. It looks like a normal GraphQL query, except it has subscription, right? And then here, we're pushing the data back, okay? And all that's happening here, basically, from a client perspective, is this example uses raw JavaScript and raw WebSockets. There's really nothing really special going on, but I will show it very quickly. So this is the client side code. And by the way, these examples for this presentation are from Philip Kruger, who worked on a MicroProfile GraphQL implementation. So kudos to Philip. He's also been very helpful with random questions that I've had along the way. Here's the query that's being sent. Here's a new WebSocket being created. And basically, we're sending this request here. And then when we get a message back, we're basically just updating the display with the message coming back. So this actually doesn't use a GraphQL library. So this actually is a good example of how you don't actually really have to have a third-party library if you don't need to. But obviously the libraries, whether they're React or just pure JavaScript or some other framework, they make it easier to consume GraphQL. And once we get to the next section, I'll go over the server-side code because you'll find that interesting as well. So those are subscriptions. Let's see if I have any questions here. Nope, no questions so far. Okay. All right. So let's talk about implementations. So this is where the fun part is. So there are, on the client side, lots of implementations. Basically, any language you can think of, there is a implementation out there, whether you're using JavaScript or if you're using something cooler like Elm or Rust or whatever, there is pretty much some implementation you can use. You'll find a lot of projects will use not Apollo server, but they'll use the Apollo client side implementation. But there's tons of them out there. So it really just matters, what framework you're using and what you're kind of interested in on the front end. But I will say Apollo is probably the biggest name out there when it comes to JavaScript, both on client and server for GraphQL. Okay, and along those lines, I did want to point out one particular client library, and that is Apollo Elements. And anyone that follows me knows that I am for front-end development, other than a lot of Jakarta Faces stuff and JSF stuff I've done in the past, and I still work on sometimes, I'm really into web components when it comes to front end, because web components are built into the browser. It's a great standard for building UIs. And what's great about them is you can write a web component that can be used in different frameworks. So Apollo Elements I like because it lets you do the client-side work using web components, and you can use it with different frameworks. So you see down here, we've got Angular, Preact, React, Vue, etc. So I think if you're interested in the front-end side of things, you might want to look at Apollo Elements. So that's my plug for that. So on the Java side, there's a few different options. There's a project called GraphQL Java Tools, which has been around for a while. And what it's great for actually is schema first. It basically allows you to, there's not an example here. But it does make it easy for you to do schema first development, which I've used in the past. So it's a pretty good project. And it builds on top of this project called GraphQL Java, which is sort of the core that basically every single library uses. So if you look here, you'll see GraphQL Java. Let me find, There we go. So GraphQLJava.com. Okay, very pink. So GraphQL Java is a low-level API. So if you're interested in using GraphQL, it's probably not the best place to start unless you really get really into it. But it's the low-level API that almost every other Java GraphQL implementation is based on top of. There are some exceptions, but usually that's the case. So it's really powerful. It's basically sort of the go-to low-level API. There's another tool called DGS Framework, Domain Graph Service, and this actually comes from Spring Boot. I'm sorry, from Netflix, excuse me. It uses Spring Boot, but it comes from Netflix. It's very feature-rich, has lots of great features, and apparently it's based on Spring Boot. So that's one option. And the one I'll talk about today is MicroProfile GraphQL. So MicroProfile GraphQL is part of MicroProfile. It ships with any MicroProfile server, like Quarkus. Well, not any, but most of them, like Quarkus or Wildfly or Open Liberty and Halidon. And also, there's an implementation called SmallRye, which is sort of the core implementation, which I think you can use in other MicroProfile implementations as well. So what I'll show you is sort of how it works. And if you've worked at any version of MicroProfile or even Spring Boot, this will also seem very straightforward to you. So what we've got here, first I'll look at the subscription example because that's what I've got running. So this example, it's a normal Java app, nothing special going on. We've got an endpoint, we've got a model, and we've got a service class, okay? And the POM is pretty straightforward. Actually, there's a parent POM here, I believe, yeah. Okay. So the parent POM basically is going to be loading Quarkus dependencies, not a whole lot special going on here. So basically, any MicroProfile implementation will do. So we've got in here a person endpoint, okay? And again, this is the subscription implementation. So what you didn't see when I was running the subscriptions was this. This is output. So you see it's still pushing out data. So if I go back to my client here, you'll see it's still updating. So 233, here we've got 233, 234, etc. So basically, the MicroProfile GraphQL implements, integrates very easily with the way any MicroProfile application would be written. So we've got this person endpoint, we've got this GraphQL annotation, which you'll need. We can inject our person service, whatever services we need. There are some queries, which we'll talk about in a minute. And then there is the subscription. Okay, so you've got subscription annotation. And again, the subscription features are experimental for GraphQL, for MicroProfile GraphQL, excuse me. So take this particular implementation or example with a grain of salt, but this is generally the idea and the way it would work pretty much in any implementation you're using. So you basically say subscription, and you can see we're returning a person added listener. Okay, so let's take a look at that. And this returns multi, which is basically a publisher interface, right? So basically you see we've got methods we need to implement, like on item, stage, failure, etc. So if we go to our process queried method, you see it's got a broadcaster that you can create. Okay. And every time we add a person, we add something to there, and then we call on next, which is going to be pushing data out for us. And the random person endpoint, you notice, looks like this. So it basically does an operation every 2 seconds here using this multi-form here. And then basically for each item that's created, it goes and creates a person for each tick, excuse me, creates a person and then pushes them out, essentially. So basically we're just going through and randomly creating different objects and then pushing them out. So you notice that the API is pretty straightforward. And if we take a look at this from the other perspective, from the normal query perspective and not from the subscription perspective, this time I'm going to look at this endpoint. Okay. So I'll run over to an example here. Back in good old Altair. Okay, so here I would just want to get a query of people back, right? So I do this, I run this, and I get my query of people. And what's happened with MicroProfile GraphQL is that we're essentially doing code first. It does not support schema first. So it dynamically generates a schema, okay? And one thing I forgot to show earlier was that anytime you have a schema, which is pretty much all the time, you get free docs. So see here, I automatically know what the query, what I can query, what fields I can query. And then you can see I can basically go through the entire schema, okay? Obviously for GitHub, it's a little more interesting, but you basically can see that this supports a person query, a person's surname, the random number, all headers, people, etc. Okay, and what the schema also allows you to do, if you have any capable query tool, you get code completion as well. So let me get rid of that. So if I just do this, I can automatically get whatever fields are there. Okay. This makes it really easy to develop queries, right? Because you've got basically the ability to use the schema to discover exactly what you can send, okay? And if I go in and I send anything that doesn't actually work, I'm going to get an error back, right? So you see I get a validation error of type field undefined, cover photo is not valid, it's complaining, gets me a validation error. And all this happens before it even hits your code, okay? So if we look at the actual code, this is the person GraphQL API. So this is that annotation here. Where again, it's normal Java class. We're using the GraphQL API annotation. We're injecting our services, and we've defined some queries. We can use the normal microprofile metrics on them as well, which is handy because that's not always the easiest thing to do with GraphQL. We can use other annotations that are part of MicroProfile or Jakarta EE as well. Okay. And so this is the get people endpoint that I was just calling. And you notice it's just returns, it just has a query annotation, right? And then returns objects, and the implementation automatically serialize that for you. And one of the things you'll notice is that I'm looking for scores, right? So when I do a query, I get back all of the scores coming back, right? But if you look at the object for a person, you'll see there is no score property, right? So the way that scores are sent back is basically with another query. So this source annotation basically says that the scores property, the source of it is person. So basically, if someone requests scores on people, on a person object is getting back, the implementation is automatically going to return that value from this method as well. So this allows you to do more complicated queries. So you'll see also we've got all the scores coming back here, but this is different because you're actually throwing in, actually, I'm sorry, this is going to basically do the same thing, but for a list of people coming back. And that's what we have here in our demo. So we've also got a mutation that we're calling as well. So I'm going to create a new person called Keto, great name. And after I do that, I can then, of course, get back that person. So this is ID 11, right? So So then I can get back that one person back. And what you'll see here, if I've got for scores, I've got this random exception I've thrown in just for fun, right? So let's say I say the ID is 0. Okay, I'm going to get back an exception. So you see here, I'm throwing a scores not available exception, right? But the implementation is sending back this generic data fetching exception, okay? And it's happening because it's sort of obfuscating the error, and you can configure MicroProfile GraphQL to return the real exception if you want to. You notice also that down here, it's returning the actual data. So one of the key things here is that you can actually return partial data sets with GraphQL. So if there's an error, you'll get that first, but you can also return data back. So that helps in situations where you've got multiple data sources you're talking to. Maybe one is down or not available. You can still return the data that's available back to the client. The client can decide if it wants to just move on or not, or display or work with the partial data. Okay. All right, so we've got a question here. Does GraphQL fetch only required filter data from DB, or it gets entire record, document, and filters before sending it to the client? Yeah, so by default, think of it this way. GraphQL doesn't care. GraphQL doesn't really care what you're, how you're getting data. All it knows is that when it gets the data itself, it's only going to do the filtering for you, okay? So in this example, you see we're returning the entire person object or list of persons, right? Now, if we wanted to, we could get a better handle on the query, get more metadata about what the query is, and return only certain fields from the database. Generally, that's not what you do, though. Generally, you kind of are, you take the simple approach and just grab the data and then let GraphQL do the filtering for you. But you could, if you wanted to, be a little smarter about it. And usually what you'll find in situations like that is that's where you kind of need to go down to the actual API of GraphQL. So for example, down here, we've got the ability to observe parts of the low-level API. So you can look at how the schema was built. And there are other layers too, where you can look at the actual query that was being sent in. So hopefully that helps. Okay, so in terms of the demo, I think that's pretty much it. You can see it's pretty straightforward. It's like, writing a REST service, essentially, when it comes to the implementation. Obviously, there's more stuff you can do, but this is the basic idea, is you basically just write methods, use annotations, and the GraphQL implementation takes care of more of the work of parsing the query and passing you the right data and all that kind of fun stuff. Okay, so let's move on. There's also, if you are in the Spring Camp, there's a Spring GraphQL implementation, which just came out. Actually, well, 1.0 just came out relatively recently, and it's very full-featured as well. On the server side, for Node, Apollo server is probably going to be your most popular choice. And there's also an Apollo federation feature, which allows you to basically federate multiple GraphQL APIs together, which can be useful in larger organizations. So that's pretty cool. Someone says, what's the relation between GraphQL and JDC? Not really sure what JDC is in this context. Oh, JDBC, thank you. Yeah, so JDBC is just a way to query a relational database. So it's very specific to databases. GraphQL is an API layer, so it doesn't care about the database at all. All it cares about is the ability to send the process queries and send queries back and forth. So GraphQL is data agnostic, whereas JDBC is specifically about talking to relational databases. So hopefully that helps. Here's another question. Actually, we already answered that one. So someone just reposted the question about fetch only required data. And my answer to that was that the GraphQL doesn't care what data you request, but it will do the filtering for you. So if you return an entire object or an entire set of objects, it will do the filtering for you before it sends it. And if you want to do additional filtering before you return data, then you've got to do that yourself. Hopefully that answers the question. Okay, so we did the demo, and there also are lots of tools out there. There's code generators, there's a CLI that I have not yet played with, but looks interesting. Also, there are APIs, libraries, excuse me, for Angular, React, Swift, etc., etc. So lots of great tools out there. And a lot of these you can find on graphql.org. So it's a good place to start. On the database side, you can imagine that any graph database is going to very likely provide a GraphQL interface. So any database that's usually used for, and representing graphs almost always will have the ability to support GraphQL out of the box. And I've been looking at Neo4j, which has some great stuff in there for supporting GraphQL. So that's one way that, if you are using a graph database, you may just be able to generate the GraphQL API without having a layer in between, which can be nice. And as you can imagine, since GraphQL is really well suited for being a backend for front end, for being essentially an API that consolidates several data sources, that it's also becoming a very popular choice for service providers, for cloud providers. So AWS AppSync actually does this. So you can configure a GraphQL API that talks to different AWS data sources, including DynamoDB. You can write Lambdas, all sorts of fun stuff like that. Another one that I've seen a lot of is StepsIn, which is a startup, but they've got a great product that allows you to basically consolidate several different REST APIs and also talk to relational databases and other databases and consolidate those with the GraphQL API as well. So if for whatever reason your organization needs GraphQL support and doesn't, and you're more interested in wrapping existing data sources or existing REST endpoints, then one of the service options might be good for you. Oops. All right. So why would you not want to do GraphQL? So nothing's perfect, right? Some of the benefits are also drawbacks, right? You can't just write an endpoint. You have to actually do the schema, or you have to do schema first. Code first, where you write the code first and then generates the schema automatically. The client needs to know what data it wants. What if your client just wants to get all the data back? There's really no way to do that. You can't say, give me all the data. You have to specify exactly which fields you want. I have no specs or no benchmarks saying GraphQL is slow or anything like that, but there is additional overhead because all that parsing of the query and filtering of results, that's something that is happening. So if your requirements don't need all that, then you're adding additional overhead and complexity, which may not be necessary. Another drawback, of course, is that it's not REST because, people know REST. It's easy to use. People are used to it. And another drawback is that it's more magic, right? There's a lot of stuff going on that in between the request and your code, which some people don't like. So that's something to keep in mind. And REST is simple, easy to get started. It's better suited for read-only or low data APIs. So, if you just are basically sending a whole bunch of post requests to update something, there's no reason to use GraphQL. GraphQL is really well suited for getting a lot of data back and also for the subscription stuff. And also, if you don't want JSON for format and you want to use some other data format, obviously GraphQL is probably not the best choice. Although I'm sure you probably could implement it using another data format. By default, it's going to be all JSON. Okay, so that's pretty much it. Here are some resources. There's the GraphQL site. And I'll make sure that I think I can post this slide somewhere. If not, I'll just tweet about it. You can follow me at Keto99 on Twitter. And there's the GraphQL site is graphql.org. And of course, you should look at the, you can look at graphql.java.com as well, if you're interested in that. And of course, there's MicroProfile GraphQL as well, which you can just search for on GitHub or look at microprofile.io. And that's pretty much it. So I think we're at time. I don't know if we have time for questions or not, but
Yes, no, we definitely do. So thank you for that excellent presentation today, Keto. And just a reminder, if anyone in the audience does have any final questions, there's 2 areas where you can post them. You can put them in the chat section, or you can post it in the Ask a Questions tab while I wrap up. So again, just wanted to highlight the next Jakarta Tech Talk happens on June 28th, and it's the Jakarta EE 10 release celebration. So you can register for that session using the link I will be posting shortly in the chat. Also, we are looking to book more tech talks. So I will be also sharing the link where you can fill out the form and submit a talk for your next presentation. So let me just have a quick look here to make sure we don't have any questions here. And let me click on the Ask a Questions, and there's no questions in there neither.
okay.
All right. So if you have any feedback on the Tech Talk program, we would love to hear from you. So just click on the green button that pops up when we end the live and provide your feedback there. Thank you so much, Keto, for today's presentation.
Thank you. Thanks for having me. Thanks
Thank
for
you.
everybody.
See you later.
All right.
Bye.
Bye-bye.